Hello, welcome to the third day of this lesson. It's the second day of 6.2. Today we're just going to explore some more properties of probabilities. The first property is two events, A and B, are independent if knowing one occurs does not change the probability that the other occurs. And if A and B are independent, probability of A times the probability of B is going to be the probability of A and B. This is called the multiplication rule of independent events. Now, another way to write this, A and B is the same thing as probability of A intersection B. It's the probability of A times the probability of B. This is a good method for checking if two events are independent. If we want to figure out if two events are independent, what we can do is just look at their probabilities and see if this works. And if it is, they are independent. All right, the probability that John makes a free throw in basketball is 0.45, and the probability that he gets an A in AP Stats is 0.75. Let's assume that these events are independent. Use a Venn diagram and a tree diagram to find these two probabilities. All right, so first I'm going to draw a Venn diagram. So the probability that he makes a free throw is 0.45. The probability that he gets an A in AP Stats is 0.75. Now to find the probability that both of them occur, I'm going to take 0.45 times 0.75. And that's 0.3375, so let's say that's 0.34, just because I don't have a lot of room here. So 0.34 is the probability that both of those things occur. Now this first circle is the probability that he makes a free throw in basketball. The whole circle contains 0.45. So what would be the probability out here? Well, we take 0.45 minus 0.34, and that would be 0.11 would be the probability that John makes a free throw but doesn't get an A in AP Stats. 0.75 minus 0.34 will give us this section. So that would be 0.41, I believe. Yep. So that would be the probability he gets an A in AP Stats, but he misses the free throw. Now, if I want to find the probability that he doesn't do anything, first we'll add up all these probabilities. So I'm going to take 0.11 plus 0.34 plus 0.41. That's 0.86. Now if I take 1, subtract 0.86, I'll get 0.14, and that will be on the outside. That's the probability he doesn't make anything. So this is a Venn diagram that shows all of these solutions. Now, let's answer these questions and then I'll show you the tree diagram. What's the probability that John does not get an A in AP Stats but makes a free throw? So he doesn't get an A, but he makes a free throw. That's going to be 0.11. John does not get an A or make a free throw. That's going to be on the outside, which is 0.14. Look at how easy it is once you have the Venn diagram to find everything else. Another way we can do this is with a tree diagram. The first thing you do is, say with basketball, he, let's say, makes a shot or he doesn't make a shot. And then the next probability is he gets an A in AP Stats or he doesn't get an A in AP Stats. And remember, it doesn't get an A is A complement. So now we have to fill in the probabilities. The probability that he makes the free throw is 0.45, so the probability that he doesn't is 0.55. Now the probability that he gets an A in AP Stats is 0.75, so the probability he doesn't is 0.25. Now to find the probabilities of these occurring, you multiply along the branches. 0.45 times 0.75 is 0.34. The probability, or 0.45 times 0.25 is going to be 0.11. 0.55 times 0.75 is 0.41. 0.55 times 0.25 is 0.14. Notice how these probabilities are the same as the probabilities over here. It's just a different method for doing the problem. All right, the probability that the Vikings win a game is 55%. The probability that the Timberwolves win a game is 25%. What's the probability that the Vikings win and the Timberwolves lose? All right, so we could pick any method. Let's try the Venn diagram again. So if I do this, I would do 0.55 times 0.25, which is about 0.14 for the middle. So if I take, say this is Vikings, this is Timberwolves, 55 minus 0.14 is 0.41. 25 minus 0.14 is 0.11. So on the outside here, we take 0.41 plus 0.14 plus 0.11. Subtract that from 1, and you'll get 0.34 on the outside. So now if we look at this, what's the probability that the Vikings win? So it's inside of this circle, and the Timberwolves lose, so it's outside of this circle. So it has to be this probability, which is 0.41. So there's a 41% chance that that will occur. All right, now we get into some controversial issues. Condoms. I don't know how controversial it is, but in the effectiveness of male condoms. From a website, a study on condoms found that condoms are 99.8% effective at preventing pregnancy each time they are used. Sounds like a pretty high percentage. If a couple uses a condom 10 times, what is the probability that a female will be pregnant? Now, if we look at this, if I wanted to find the probability that she gets pregnant every single time, I would take 0.002 times 0.002 and so on times 0.002, and I do that 10 times, which is going to be 0.002 to the 10th power. Now what this is the probability of is that she gets pregnant on every single time that the couple uses the condoms. Now if we want to find the probability that she doesn't get pregnant at all, we take 0.998 times 0.998 times 0.998 and so on, and so that would be 0.998 to the 10th power. So if I take 0.998 to the 10th power, the probability that she doesn't get pregnant is 0.98. And there's some more decimals coming out there, but so the probability that she doesn't get pregnant is 0.98. So now what is going to be the probability that she gets pregnant at least once? Because you just need to be pregnant once, or get pregnant once to be pregnant. So what we do is we take 1 minus 0.98, which is 0.02. So if the couple has intercourse 10 times, then there will be a 2% chance that they will get pregnant. Now, in this study, the average couple in that study had sex an average of 88 times in a year. So what's the probability that the female became pregnant in that year? So what we have to do is take not the probability that they won't get pregnant to the 88th power. So 0.998 to the 88th power. That's 0.8388. So it's a decent percentage of the time nobody gets pregnant, but I take a 1, subtract that to find out the probability of getting pregnant. So 1 minus that answer is 0.16, about 0.16. So the couples in that study had a 16% chance of getting pregnant, even though the effectiveness of condoms was 99.8% for each one. So the more often you use it, the more the probability of one time occurring increases. Now, we're going from condoms to AIDS. A certain AIDS test is given to 200 women in a village hospital in Africa. Is It has a probability of giving a false positive at 0.004. So the probability that a woman comes in and they tell her that she has AIDS, but she really doesn't, is 0.004. What is the probability that at least one of the women had a false positive? So what's the probability at least one woman walked away thinking she had AIDS, but she really didn't? So the probability that everybody had a false positive would be 0.004 to the 200th. That's such a low percentage that it just wouldn't happen. So about 0. Now, that's everybody has a false positive. Let's find the probability that nobody has a false positive. That would be 0.996 to the 200th power. So 0.996 to the 200th power, my calculator says that is 0.44, let's do 0.45. So about 45% chance that nobody has a false positive. So the probability that there's one false positive is 1 minus that, so that's about 0.55. So there's a 55% chance that at least one of those 200 women is going to go home thinking that she has AIDS when she really doesn't. That could be pretty traumatic in that situation. So even though it has a low percentage here, a low probability, when it's done over 200 women, you can see that the percentage of at least one time of it occurring increases dramatically. All right, here's your homework. Good luck.